Okay, so here I have written it in a cleaned up form. Now let's try to actually compute what d alpha should be for a given microfacet distribution function. Now in the literature there are several functions. Okay, so one of the most common functions known is the Beckman microfacet distribution. There are some other functions, but there's also a simple function called Blin's microfacet distribution function, and I would like to use that one as an example because it's easier to understand. But in the literature there are really many other distribution functions, but for all of them we will be using the same process. So now let's focus on the Blin because of its simplicity. So the Blin microfacet distribution function, Blin d alpha, is very simple. It's just cosinus alpha to the power of p. Okay, so it basically says that you have more. So let's understand what's cosinus alpha. The cosinus alpha function, if you like plot cos from 0 to pi over 2, it's going to be a function like that, right? So really like it's symmetric. Okay, so this is kind of like the Blin's microfacet distribution function, and by playing with p you can actually make this function to be more narrow or wider. Okay, so it just says that you have more this function just says that you have more microfacets when alpha is 0. So more microfacets that are oriented which are aligned with the real geometric normal, and fewer microfacets as you go away, as alpha becomes further away from the geometric surface normal. Okay, so let's use this one. Now this function, microfacet function, is not normalized yet, but we will normalize it using this integral.